accepted by the regular expression, that should have one accepting state, that should reach to starting stage to the accepting state, right? So the finite automata accepts only one because it is going to the starting state to the accepting state. Here the finite automata accepts any ones. It is like one I can take 1 0, this is also accepted by this one, 1 1 0, this is also accepted, but 0 1, this string is not accepted by this finite automata. Why? Because for 0 you can go to from this state, starting state, from starting state you can go either for 1 or 0. So the input string is, first we are taking 0, so we will go 0 to this state, that is accepting state, and now we are not having any state, any transition from this final accepting state, right? So to generate this symbol, input symbol, so this input string is not accepted by this finite automata. So these are some examples. Okay, now next we will see so the regular expressions to how to generate regular expressions to NFA and NFA to DFA, and we can optimize this DFA also. Later we can see the lexical analyzer generator. Okay. I think you already know how to generate from regular expressions to NFA, but I will tell you one small example. So by NFA, how to convert regular expressions to NFA by using one method, that is Thompson method. Okay, so in the NFA you can have from one state, you may have, suppose from one state to another state I have a symbol, and from the same state to, and this from same state to another state I may have the same symbol, right? You may have multiple transition for one input symbol in a given state. I'm having two transition for the input symbol A for this one, so this is NFA. But in the DFA you have only one transition for one input symbol. That is the difference for NFA and DFA, and NFA will include the epsilon moves also. So we will see how to generate NFA. So by using Thompson construction we can generate NFA for each regular expressions. Suppose take this one, so this is NFA for A, only for A from S0 state to S1 state, this is NFA. The regular expression is AB, so for this AB the NFA is, first generate separately, like you can see NFA for A is this one, NFA for B is this one, NFA for A, NFA for B is this one. We are constructing the regular expression, we are constructing NFA for AB. Okay, first construct for A and then B, then we need to combine these two by using the epsilon move. Okay, now this is the A1, this is the B1. Now we need to construct this one, we need to add these two by using epsilon state. Okay, so this is NFA for AB. Now NFA for A or B, right? So A or B, so take how to generate, first generate NFA for A, next generate NFA for B. So now it is not consecutive A and B, it may be A or it may be B. So we need to have here one state that should be either for this one or this one, right? So here you may go epsilon move from this state to this state or this state to this state, and this 2 should be end. This 2 should have one accepting state, so this may be the epsilon moves. So this is a Thomson construction for the A or B. Now we will see for the A star, NFA for A star. First generate A, next include, this is for A, right? Next include two states, one is the initial state and the other one is the accepting states, and include one epsilon move from one epsilon transition from the ending state to the starting state of a input symbol, and generate one epsilon move from the starting state to the accepting state. Okay, so try this one. NFA for A and B or C, it will be like star. So first, for which one you need to generate the NFA? First generate for what is first generate B or C. What is NFA for B or C? We need to generate first. We need to generate S1, S2, okay, B, and separately I am generating for S3, S4 for C. A, B or C, right? So it should have one state like S5 that should go to this state and this state with the epsilon move, and this should have one state that is S6 which will be the accepting stage. Okay, now I have constructed B or C, right? So what is the A star NFA? We need to have the another two states, that is S7 and S8, okay, and this should have the epsilon move and this should have epsilon move, and from the starting state to the ending state we need to have one epsilon move, and from the initial state to the this one we need to have one epsilon state. This is completed, right? Now we need to include the A1. Just include one another state here, that is S9 to this one A and epsilon, right? So like this you need to convert the regular expression to NFA. Okay, you can see this. Try to convert more examples for the regular expressions from NFA, then you can understand how to generate. Okay, now we will generate the NFA, what is a converted NFA, then to the DFA. Okay, I think you already know how to generate this one. I am not going to tell you, but I will just show you one small example how to do it. This is a NFA for the A or B whole star A B B B. Okay, now we need to convert this NFA to the DFA. How we need to convert? Take the input, take the starting stage and give the epsilon closure of 0. Epsilon closure of one state is nothing but the directly or indirectly it should have the epsilon moves. The states that is having the directly or indirectly epsilon moves. From 0, what are the epsilon moves? Here from 0 you can go to 7, you can go to 1, you can go to, I told you that directly or indirectly, right? So it is a direct one. The indirected one, from 1 to 2 you may go to epsilon move, from 1 to 4, okay, and I think the state itself is also one epsilon closure. Okay, so these are the epsilon closure for this one. Okay, and we need to see, and we need to assign this into one symbol, that is A, and we need to see the input. Normally the input symbols are A. Now we need to see the transition from whatever we are having 0, 1, 2, 4, 7. So from this to input symbol A, these all whatever states here, any state is having the input symbol A or not. any symbol is having the transition of A or not. So we need to check. 0 is having input symbol A, no. 1